Hello there, Earth Science people. I hope you're having a good, restful vacation. And I hope you're staying well and healthy and happy. Try to get out now and then. So last week you got to read chapter 18, where you learned a little bit about water in the atmosphere. Today what I'm going to do is show you a couple of demonstrations that normally you would have done in class, but this is what we have to do right now. So this is right here. You see all the things that we need for our experiment. There's actually two parts to this experiment. So I have a water bottle, empty. Okay, except for air is in there. This is a pressure pumper, it's called, also known as a fizz keeper. You use it to keep the fizz in your soda bottles. Okay. Matches and water, that's for part 2. And no, the water is not to put out any potential fires that I would start. This right here is a thermometer. And it could be used, some people use this on the sides of their fish tanks to show the temperature of the water. But if you look closely, you can see where the number 66 and 68 are kind of lit up in blue and kind of a brownish color. That gives you, the temperature. So what we're going to be doing is we're going to put this into the bottle, and then we're going to put the fizz keeper on top of the bottle, and make sure it's screwed on tightly. And notice, the bottle does have some give, right? And there is some air in there, but what we're going to do is we're going to pump this up, okay? And take some observations. So air is being pumped in there. So the question is, what's happening to the pressure inside the bottle? But you can see when I squeeze the bottle, I can tell you that there is some resistance. So we'll pump it up a few more times, and then we'll take a look at the temperature. Remember, the temperature before was about a 66 to 68. So about 67 degrees, that's Fahrenheit. Alright, let's take a look-see. See if we can see it in the bottle. Yeah, look at that. Might be kind of hard to see, but 76, 78 degrees. So we increased the temperature about 10 degrees in there. Okay, so increased pressure. You can see the bottle is pretty stiff. Increases the temperature. Okay, so this type of a temperature increase is referred to as adiabatic. That's the fancy scientific word for that. Adiabatic temperature changes refer to temperature changes in response to changes in pressure. So if we increase the pressure by pumping the bottle, how can we decrease the pressure? Well, we can take the cap off. And as we do that, let's take a look at what happens to the temperature inside. Well, it's down to 70 already. So as we take the cap off, the pressure goes back down, and so does the temperature. It's magic. Okay, well, the environment inside our chamber here was dry. We're going to add a little bit of water to it, because in our atmosphere we do have some water in the form of water vapor. So I'm going to put a little bit of water in the bottom of the jar, okay, and I'm going to shake it up. So we've introduced water to this by shaking it. I'm going to add some water vapor to the bottle. And the other thing I'm going to add is a little bit of smoke. Okay, so I'm going to light a match. Okay, be careful not to burn myself. And I'm going to blow it out and drop the match in there. There's a little bit of smoke that gets into the bottle. Okay, so we've introduced two new things into our little experiment: water and smoke. And you can see some water on the side of the water droplets here on the side of the bottle. I'm going to try to ignore those, but we're going to increase the pressure by pumping up our pressure pump. Once again, I can feel the pressure increasing on the inside. And if you look at the inside of the bottle, you can see right through it. Yes, you can see my hand behind it, right? Pretty clearly. There's a little bit of glue on the side of the bottle here. But if we increase the pressure, things are pretty clear. Watch what happens when we decrease the pressure. Lo and behold, we formed a cloud. So that's how clouds form. Clouds need 3 ingredients. It needs low pressure, in other words, low temperature, correct? We need water vapor. We also need something for the water vapor to condense onto. That would be the smoke particles, and the fancy word for that in science speak is condensation nuclei. So once again, the 3 ingredients to make a cloud: water vapor, low pressure, aka low temperature, and condensation nuclei. That's 3. All right, thanks for listening. Take care, everybody. Hope to see you soon.